Okay, so today we're going to continue on with our discussion of classes, and we're going to cover accessor, mutator, and constructor functions, which are very important for making our classes operational. So far we've looked at the fundamentals of object-oriented programming. We've explored the idea of natural behavior systems and how we can model these in programming and build programs that emulate these using object-oriented programming. We also talked about using UML, Unified Modeling Language, a little bit to model classes and to help with our planning of developing them. And we've also seen how to define a class by giving its name, attributes, and operations in the form of function declarations. And we've seen how to use a class. And we've also discussed a little bit of the difference between public and private for class members. And finally, we had that lab where we learned how to instantiate a class and use class functions, assuming that everything else is nicely defined for us. So in object-oriented programming, you need to wear two hats. One, you need to be able to write the class, that is, define the member variables and functions so that it can be used. And the other hat that you wear is the one that we had on during the last class session, which is where you write the application code in order to use the class. In a big project, two different people or groups of people will perform these two separate tasks. But in CS150, you'll be wearing both hats. So one of the things you need to define are accessor and mutator functions. These are the getters or setters. And that's because in most object-oriented design, all the member variables are private. Accessor member functions return the value of a member variable, and basically they give the main program the ability to see or to use those values. At a minimum, you need to include an accessor function for each member variable. Typically, it'll have a return value, almost always non-void function that returns a member variable. And these are extremely simple functions to write, and basically they consist of usually a single return statement, unless we're doing something special with them. So if we declared int get age as part of a declaration for a student class, then at the bottom we would write the function definition, which would be int is the return type. It belongs to the class student. The scope resolution operators and the function is get age with no parameters needed. And the function body is just return age. So very simple to write. And later on, we'll see how we can actually write them in line to save a little bit of space. Mutator functions, on the other hand, allow you to change one or more member variables. And basically, you'll write these for each member variable since the member variables are private. And again, the idea of encapsulation, you allow the class to control how it changes its member variables. So here we have a function set age. It doesn't have a return type, but it takes a parameter of type A or called A that is of type int. And then we will write the function, it's again void return type. Student is the class to which it belongs. The name of the function is set age and takes the parameter of A, which is of type int. And then we just said age is equal to A. So again, very, very simple to write these accessor mutator functions. The other one that we have to write are constructors, and these are when you're going to make a new member of the class. So basically, when we declare an object or perform the initialization of member variables, that's when we call the constructor. And it does the same thing for object-oriented objects that a declaration for ordinary variables does. And constructors get called when the object is declared. There are some peculiarities for the syntax for the constructor function. It needs to have the same name as the class, and they don't return a value and has neither data type nor void in the function header. So let's see how to write one of these. Say we wanted to write a constructor for our student class. We'd have the following declaration in the class definition. First name, last name, age, and GPA would be the things we'd be interested in passing to it. Those would be of type string, string, int, and double. And then at the bottom, we put in the function definition. And so this is going to be part of the class student. The name of the function is student. It's a constructor. Here are the parameters that we're going to pass it. And then we set the first name is equal to first, last name equal to last, age is equal to A, and GPA is equal to G. And that completes our overloaded constructor. Now you can have multiple constructors associated with your class. The default one is one with no parameters, and basically you define and declare it in the same way as you do with the others. However, when you invoke this with no parents, not empty parents. So like a default constructor for a student is shown here, student John, no parents. So next time we'll see how to separate this idea of the class declaration and the class definition in the actual class use using an idea known as abstract data types. So that's all for now. Thanks so much for listening.